The National Electrical Code, commonly referred to as the NEC, does not specifically dictate the orientation of electrical receptacles. An exception exists for specific applications such as those found in hospitals and wet locations. However, despite the lack of a definitive code requirement, industry practices and general recommendations provide guidance on the preferred orientation. The most common orientation is with the ground prong down. This orientation is favored for several reasons. Firstly, it tends to provide better contact with the grounding wire within the outlet box. Secondly, the downward orientation often offers a more stable connection, particularly when the attached plugs have cords that may become loose over time. Thirdly, it is believed to prevent accidental polarization reversal should a plug be inadvertently inserted upside down. Although less prevalent, some installers opt for the ground prong up orientation. This choice is occasionally driven by aesthetics, as it can create a more symmetrical appearance. It can also be applied in scenarios where there is an elevated risk of water or debris intrusion into the outlet, such as with outdoor receptacles. Several safety considerations are relevant when determining receptacle orientation. Polarization is a crucial aspect. The ground prong and the neutral slot are intentionally designed to be non-interchangeable. Installing a receptacle with the ground prong positioned upwards could enable polarized plugs to be inserted improperly, leading to potential safety risk. Another consideration is the risk of accidental contact. A receptacle with the ground prong facing up might increase the likelihood of unintended contact with the hot terminals, especially if the cover plate is removed. Also, the secure connection of wires can be affected. If a receptacle is installed with the ground prong in the upward position, it may be more challenging to ensure that the ground wire remains securely connected. In conclusion, based on established industry practices and paramount safety considerations, the general recommendation is to install electrical receptacles with the ground prong oriented downwards. This configuration promotes a more dependable connection, mitigates the risk of accidental polarization reversal, and lessens the potential for accidental contact with live wires. To elaborate further on the reasons for the ground prong down recommendation, let's consider each point in greater detail. Improve grounding contact. The grounding system is a critical safety component in any electrical installation. Its purpose is to provide a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or ground fault circuit interrupter, commonly referred to as a GFCI, and quickly de-energizing the circuit in the event of a fault. When the ground prong is oriented downwards, gravity assists in maintaining firm contact between the plug's grounding pin and the receptacle's grounding contact. This is especially important over time, as receptacles can loosen slightly with repeated use. A secure ground connection ensures that the grounding system can effectively perform its safety function. Stable connection. The weight of the plug and any attached cord can exert a downward force on the receptacle. When the ground prong is down, this force helps to maintain the plug's position within the receptacle. This is particularly beneficial for plugs with cords that are prone to becoming loose. A stable connection reduces the risk of arcing, overheating, and potential fire hazards. Polarization reversal prevention. Polarized plugs are designed with one blade wider than the other. This ensures that the plug can only be inserted into the receptacle in the correct orientation, maintaining the intended polarity of the circuit. While not a guaranteed prevention method, having the ground prong down can deter the unintentional insertion of a polarized plug upside down, which could lead to appliances or equipment being improperly energized, creating a shock hazard. Now, let's consider the less common practice of ground prong up. Aesthetic considerations. Some individuals may find that having all the receptacles in a room oriented with the ground prong up creates a more visually appealing and symmetrical appearance. This is purely an aesthetic preference and does not offer any functional advantages. Risk of water or debris. In specific situations, such as outdoor installations or locations prone to spills, some argue that having the ground prong up can prevent water or debris from easily entering the receptacle. While this may offer a slight benefit, it is not a substitute for proper weatherproofing or using ground fault circuit interrupters. Regarding safety considerations, there are important factors to keep in mind. Polarization is essential for the correct operation of many electrical devices. Incorrect polarization can lead to equipment malfunction, shock hazards, and even fire hazards. As mentioned earlier, installing a receptacle with the ground prong up can increase the risk of accidental polarization reversal. Accidental contact. If the cover plate is removed from a receptacle with the ground prong up, the hot terminals may be more exposed and accessible, increasing the risk of accidental contact. This is especially dangerous for children or individuals unfamiliar with electrical safety. Loose wires. Maintaining a secure connection is paramount for electrical safety. With the ground prong up, the weight of the wires can potentially pull the ground wire away from its terminal, leading to a loose connection. A loose connection can cause arcing, overheating, and potentially a fire. To further clarify the points made about industry practices, one could consult with licensed electricians and electrical inspectors. These professionals have extensive experience with electrical installations and are knowledgeable about the relevant codes and best practices. They can offer valuable insights into the reasons why ground prong down is the generally preferred orientation. Now, let's consider the perspective of electrical inspectors who play a crucial role in ensuring the safety and compliance of electrical installations. Electrical inspectors are responsible for verifying that electrical work meets the requirements of the NEC and local codes. They typically look for installations that are consistent with industry best practices and minimize potential safety hazards. While inspectors may not explicitly fail an installation solely for having the ground prong up, they may point out the potential safety concerns and recommend that the receptacle be reoriented. Now, let's delve into the electrical code itself for further details. The NEC is a comprehensive set of standards for electrical installations. While it does not explicitly mandate the orientation of receptacles in most cases, it does contain requirements related to grounding, polarization, and other safety aspects that are relevant to this discussion. Article 210. 7 of the NEC addresses the use of grounding-type receptacles. It requires that receptacles installed on 15 and 20 amp branch circuits be of the grounding type and that the grounding contacts be effectively grounded. This article reinforces the importance of a properly functioning grounding system. Article 406. 4 discusses the installation of receptacles. It specifies requirements for mounting, support, and protection of receptacles. While it does not dictate orientation, it does emphasize the need for secure and reliable connections. Article 517 addresses healthcare facilities. In these settings, the NEC requires that receptacles in patient care areas be listed as hospital-grade. Hospital-grade receptacles are designed to provide a more reliable and durable connection and are often required to be installed with the ground prong up to minimize the risk of accidental disconnections. Furthermore, it's important to address some common misconceptions about receptacle orientation. Firstly, it is a misconception that ground prong up is inherently safer in wet locations. While it may offer a slight advantage in preventing water from entering the receptacle, it is not a substitute for proper weatherproofing. Outdoor receptacles should always be protected by a weather-resistant cover, often referred to as an in-use cover, that is designed to prevent water from entering the receptacle regardless of its orientation. Secondly, another misconception is that ground prong up is more aesthetically pleasing. Aesthetics are subjective, and while some may prefer the symmetrical appearance of ground prong up, others may find it less appealing. The most important consideration should always be safety and compliance with industry best practices. Finally, to reiterate the key takeaways, the NEC does not generally specify receptacle orientation. Industry practice favors ground prong down for safety and reliability. Ground prong down offers better grounding contact, stable connection, and potential prevention of polarization reversal. Ground prong up is sometimes used for aesthetics or perceived water protection. Safety considerations should always outweigh aesthetic preferences. Consult with a qualified electrician for specific installation questions. The information provided here is intended for general knowledge and informational purposes only, and does not constitute professional advice. It is essential to consult with a qualified and licensed electrician for any electrical work or installations. Electrical work can be dangerous and should only be performed by those with the necessary training and experience. Incorrectly installed electrical wiring can lead to shock hazards, fire hazards, and other serious consequences. Always follow all applicable electrical codes and regulations and prioritize safety when working with electricity. Now, to add another layer of detail, consider the implications of using different types of electrical testers to verify the proper wiring and grounding of receptacles. A receptacle tester, also known as a circuit tester or plug-in tester, is a simple device that can be plugged into a receptacle to check for common wiring errors, such as reverse polarity, open ground, or hot neutral reversal. These testers typically have 3 lights that illuminate in different patterns to indicate the wiring condition. While a receptacle tester can identify some wiring problems, it cannot detect all potential issues. For example, it cannot detect a bootleg ground, where the ground wire is improperly connected to the neutral wire. A more sophisticated tool is a multimeter, which can measure voltage, current, and resistance. A multimeter can be used to verify the voltage between the hot, neutral, and ground terminals of a receptacle. It can also be used to check the continuity of the ground wire to ensure that it is properly connected to the grounding system. An even more advanced tool is a ground impedance tester, which can measure the impedance of the grounding path. A low impedance grounding path is essential for ensuring that fault current can quickly return to the source and trip the circuit breaker or ground fault circuit interrupter. Now, let's discuss some specific scenarios where the choice of receptacle orientation might be more critical. In a workshop or garage where power tools are frequently used, it is particularly important to ensure that the grounding system is functioning correctly. Power tools often have metal housings, and if a fault occurs, the housing can become energized, creating a shock hazard. A properly grounded receptacle with the ground prong down for optimal contact can help to minimize this risk. In a kitchen or bathroom, where water is often present, ground fault circuit interrupters, or GFCIs, are required for all receptacles serving countertops. A GFCI is a device that monitors the current flowing through a circuit and can quickly de-energize the circuit if it detects a leakage current to ground. While a GFCI provides a high level of protection, it is still important to ensure that the receptacles are properly grounded. Now, to address another common question, let's consider whether it is acceptable to replace a 2-slot receptacle with a 3-slot receptacle in an older home that does not have a grounding wire. The NEC addresses this situation in Article 406. 4D. It allows for the replacement of a non-grounding receptacle with a grounding type receptacle where a grounding conductor is not present, provided that one of the following conditions is met. Firstly, a ground fault circuit interrupter, or GFCI, protected receptacle is installed. The receptacle must be marked GFCI protected and no equipment ground. Secondly, a grounding type receptacle is installed and is fed through a ground fault circuit interrupter, or GFCI protected circuit. Again, the receptacle must be marked GFCI protected and no equipment ground. Thirdly, a grounding type receptacle is installed and is protected by a listed outlet circuit tester. This is a less common option, but it allows for the installation of a grounding type receptacle without a grounding wire, provided that the circuit tester verifies that the receptacle is properly wired and protected. In summary, while the NEC does not generally mandate the orientation of receptacles, it does contain requirements related to grounding, polarization, and other safety aspects that are relevant to this discussion. Industry practice favors ground prong down for safety and reliability, but there are specific situations where ground prong up may be considered. Always prioritize safety and consult with a qualified electrician for any electrical work or installations.